Problem 5. In the figure below, the outside square contains infinitely many squares, each of them with the same center and sides parallel to the outside square. The ratio of the side length of a square to the side length of the next inner square is k, where k is between 0 and 1 exclusive. The spaces between squares are alternately shaded as shown in the figure, which is not necessarily drawn to scale. The area of the shaded portion of the figure is 64% of the area of the original square. What is k? First, since the problem is only asking us about ratios, we can decide what we want the outer edge of the square to be. So let's just set it as 1 for the sake of simplicity. Then let's write an expression for the shaded area. So first, this outer ring here has an area of 1 squared minus k squared. Then the next shaded area here has an area of k squared, which is this length, minus k cubed squared, which is this length. And we can just keep going. So k to the 4 squared minus k to the 5 squared, and so on infinitely. This is the shaded area, and this should be equal to 64% of 1, which is just 64 over 100, or 16 over 25. The left side we can write as 1 squared plus k squared plus, or maybe I'll just say, we can rewrite the left side as 1 squared plus k to the 4 plus k to the 8 plus minus k squared plus k to the 6 plus k to the 10 plus which equals 16 over 25, So the left side is just two infinite geometric sequences, and we can use the formula that the sum of an infinite geometric sequence is the first term over 1 minus the common ratio. So the left side becomes 1 over 1 minus k to the power 4 minus k squared over 1 minus k to the power 4, which equals 16 over 25. Then we can cross multiply, substitute in some variable like x for k squared to simplify things, and solve for the quadratic, and then find k. So cross multiplying gets 25 minus 25k squared equals 16 minus 16k to the power 4. If we let x equals k squared, just to see the quadratic more clearly, we get 16x squared minus 25x plus 9 equals 0. And we can factor this quadratic. So we see that either x equals 9 over 16 or x equals 1, which means that k, which is between 0 and 1, has to be 3 over 4 or 1. But if we go back to the problem requirements, k is smaller than 1. It cannot equal 1. So we can rule out this solution. So that means that k equals 3 over 4. And our answer choice is D. Problem 6. 6 chairs are arranged around a round table. 2 students and 2 teachers randomly select 4 of the chairs to sit in. What is the probability that the 2 students will sit in 2 adjacent chairs and the 2 teachers will also sit in 2 adjacent chairs? So we have a round table with 6 chairs. First, let's find the total number of ways that the 4 people can sit down. So first, let's pick 2 spots for the teachers and 4 spots for the students. Here we're just going to treat the 2 students as identical. We're not going to say that, if student A sits here versus student B sits here, we're not going to count that as any different from student B sitting here and student A sitting here. We could, but it would give us the same answer at the end, so we're just not going to consider that. So we picked 2 seats for the teachers, 2 seats for the students, and since order doesn't matter, it doesn't matter who sits down first, we're going to divide by 2 to get the total number of combinations. This is equal to 15 times 6 over 2, which is 90. Now let's find the number of ways that 2 students will sit in 2 adjacent chairs and 2 teachers will also sit in 2 adjacent chairs. So first, let's pick a pair of seats for the students. So that could be this pair, this pair, this pair, this pair, this pair, or this pair. That's a total of 6 pairs. Then say the 2 students sit here. Then the 2 teachers can either sit here, here, or here. That's 3 possibilities for the teachers. And finally, we're going to divide by 2 because, again, it doesn't matter if the 2 students sit down first or if the 2 teachers sit down first. So this is going to give us 9 ways that 2 students will sit in 2 adjacent chairs and 2 teachers will sit in 2 adjacent chairs. Oh, sorry, this number here should be 45. So our final probability is just 9 over 45, which is 1 over 5. And our answer is B. Number 7. In a certain alien world, the maximum running speed v of an organism is dependent on its number of toes n and number of eyes m. The relationship can be expressed as v equals k times n to the power of a times m to the power of b centimeters per hour, where k, a, and b have integer constants. In a population where all organisms have 5 toes, log v equals 4 plus 2 log m. And in a population where all organisms have 25 eyes, log v equals 4 plus 4 log n, where the logarithms are in base 10. What is k plus a plus b? First, if we take the logarithm of this equation, we should get log v equals log k times n to the a times m to the b, which equals log k plus log n to the a plus log m to the b, which equals log k plus a log of n plus log plus b log of m. And we do that because the other 2 equations we're given include log v and log v, not just v. So we want to be able to compare all 3 equations together more easily, which is why we took the log of the first equation. So now let's just focus on what happens when all organisms have 5 toes. Then we should have that log k plus a log n plus b log m, that's our equation for log v, is equal to 4 plus 2 log m. And similarly, if we focus on just when all organisms have 25 eyes, we should have that log k plus a log n plus b log m equals 4 plus 4 log n. Now these equations, so the top equation is for 5 toes, so n equals 5, and the second equation is for 25 eyes, so m equals 25. So we can actually plug those values directly into the equation. So instead of writing n here, we can write 5. And instead of writing m here, we can write 25. So now we have one equation solely in terms of m and one equation solely in terms of n. For the first equation, it has to be true no matter what value of m we plug in to represent number of i's. And similarly, the second equation has to be true no matter what value of n we plug in. So that means that the coefficient of the log m term in the first equation has to be the same on both sides. So we get a equals 2. And similarly, in the second equation, the coefficient of the log n term has to be the same on both sides. So we get, this should say b equals 2. From the second equation, we get a equals 4. So if we just go from the first equation and plug those values in, because we still need to find k, then we get log k plus a log 5 plus b log m equals 4 plus 2 log m. So log k equals 4 minus 4 log 5. If we express the right side only in terms of logs, and remember the log is base 10, then we get log 10,000 minus log of 5 to the 4, which equals log of 10,000 over 5 to the power of 4, which equals log of 2 to the power of 4, or log 16. So that means that k equals 16, and the problem asks for k plus a plus b, which equals 4, which equals 16 plus 4 plus 2, which equals 22. So our answer is C. Problem 8. Pentagon ABCDE is inscribed in a circle, and angle BEC equals angle CED, which equals 30 degrees. Let line AC and line BD intersect at point F. And suppose that AB equals 9 and AD equals 24. What is BF? So I'm going to draw the pentagon like this. We have A, B, C, D, and E. BEC equals 30 degrees. CED equals 30 degrees. AB equals 9. AD equals 24. We want to find BF, where B is the intersection of AC and BD. Alright, so first, we know that two of the angles are 30 degrees, and we can find that a lot of other angles are congruent to those 30 degrees by finding the angles that cut off the same arcs on the circle. So for example, arc CD is also cut off by this angle and this angle here. And arc BC is also cut off by this angle and this angle. So let's focus on triangle ABD first, because we know two sides of this triangle and the angle in between those two sides, so we can use the law of cosines to find BD. Specifically, BD squared equals 9 squared plus 24 squared minus 2 times 9 times 24 times the cosine of 60 degrees, which equals 81 plus 576 minus 216. Which equals 81 plus 360, which equals 441. Thus, we get BD equals 21. Now, looking at triangle ABD again, we can see that segment AC is essentially an angle bisector. So we can apply the angle bisector theorem, which tells us AD over DF equals AB over BF, and substitute in the values we know. So 24 over 21 minus BF equals 9 over BF. Now we can just cross multiply to find BF. So 189 minus 9 BF equals 24 BF, which means that 189 equals 33 BF, and BF equals 189 over 33, which equals 63 over 11. So our answer is E.